Hello and welcome to the Chandara Academy. Today we are going to solve an exercise about limits. Let's start with the first expression. A of x is equal to x plus 1 over square root of x squared plus 2x plus 1. And we want its limit in plus and minus the infinity. So we have to see that here we will have a limit that has the form of infinity over infinity. And this is an undefined form. We don't want that. So in this situation, when you have something a bit polynomial here and something a bit polynomial here, you want to find what is the most powerful thing at the top and at the bottom. So at the top, when x tends to plus or minus infinity, 1 will not be powerful compared to x. So I want to factorize by x. So x times 1 plus 1 over x. Okay, same thing here. I've got the square root, okay, but inside I have a polynomial. What will be the most powerful in plus or minus the infinity? It will be the x squared. So let's factorize by x squared. We'll have x squared, factor of 1 plus 2 over x plus 1 over x squared. Okay, now we can put the x squared to square root outside. We will have x times 1 plus 1 over x over absolute value of x. Sorry, not x, because square root of x squared is equal to absolute value of x. So here we have absolute value of x times the square root, so 1 plus 2 over x plus 1 over x squared. So you can see that in plus or minus infinity, these terms will go to 0, because 1 over the infinity is equal to 0. This thing here will give us the sign, so x over absolute value of x, so x over absolute value of x gives us the sign of x. If we have minus 1 over absolute value of minus 1, okay, it's equal to minus 1. So this is the sign of minus 1. Okay, if I add 35 over absolute value of 35, I would have plus 1, because the plus is the sign of 35. Now that we know it, so let's erase this thing. Now that we know it, we can easily solve our limit. So because this thing is equal to sign of x times 1 plus 1 over x over square root of 1 plus 2 over x plus 1 over x squared. And so the limit when x tends to plus the infinity of a of x will be the sign of x, which is plus in plus the infinity, so plus, and this thing will go to 1, okay? This tends to 1 in plus minus the infinity, and this thing tends to the square root of 1 is equal to 1 in plus minus infinity. So in plus the infinity we have plus 1 over 1 is equal to 1. The limit when x tends to minus the infinity of a of x is equal to minus, so the sign of x, because we are in minus the infinity, minus 1 over 1 is equal to minus 1. And we have solved the first limit. Now what about the second limit? We've got b of x is equal to cosinus squared of 3x minus 1 over x squared. So we are looking for the limit when x tends to 0, okay? And when x tends to 0, we will have cosinus that tends to 1, so we will have 1 minus 1, 0 over 0. This is an undefined form as well, okay, of the form 0 over 0. But what do we know about trigonometric functions over something like x? We know that sinus of x over x tends to 1 when x tends to 0. And we also know that for any x, cosinus squared of x is equal to 1 minus sinus squared of x. So we will first apply this thing and then this thing. So is equal to, this cosinus is equal to 1 minus sinus squared of 3x is equal to 1 minus 1, 0 minus sinus squared of 3x over x squared. But we do not know the limit of that, because let's remember that we need to add the same thing into the sinus and into the denominator. So we will multiply by 3 on the top and at the bottom. So 3 sinus of 3x squared over 3x squared. So you see that I just multiplied at the top and at the bottom by 3. And now we have the exact same things into the sinus. We will multiply, by 9. By 9, because we want to have this angle squared here. So the 3 has to be squared as well. So we will have 9 here, because we want 9x squared to be equal to 3x everything squared, because we want to have the angle inside of the sinus squared as well at the bottom. Okay, is equal to minus 9. So this one does not go anywhere, times sinus of 3x over 3x everything squared. Okay, and we know that sinus of capital X over capital X tends to 1 when x tends to 0, and that x tends to some value implies x squared tends to this same value squared, because of the continuity of the function x squared. Okay, so now this thing will tend, when x tends to 0, to minus 9 times 1 squared, because when x tends to 0, we've got 3x that tends to 0 as well. Minus 9 times 1 squared is equal to minus 9. In conclusion, we've got b is equal to minus 9. So b was the limit in 0 of b of x. Now, third limit. C, we've got limit when x tends to 0 to 3x plus 2019 pi over sine x of 2020 pi minus 4x. So we are looking for C is equal to the limit when x tends to 0 of sinus of 3x plus 2019 pi over sinus of 2020 pi minus 4x. So you see, and you should know that there will be some simplifications inside of the sinus, because we've got integers times pi, so multiples of pi, and this gives us easy simplification, because we know that sinus of some angle plus 2k pi with k in z, so sinus plus 2 pi times some integer or some negative integer will be equal to sinus x, because if you represent it on the trigonometric circle, sinus of this angle plus something like 2 pi will just do k terms around the trigonometric circle, so this will be the exact same value. But sinus of x plus 2k plus 1 pi will be equal to minus sinus of x, because we do 2k, we do k terms, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 k terms, and then we add pi. And you can see that this sinus, is equal to minus this one, exactly. So sinus of x plus 2k pi is equal to minus sinus of x. And that being said, we've got an odd multiple of pi here, so this thing is odd, so it's equal to 2k plus 1 with some k. So this thing here will be equal to minus sinus of 3x. And this thing here will be equal, because here we have an even multiple of pi, will be equal to sinus of minus 4x. And we remember that sinus of minus an angle is equal to minus the sinus of this angle. So let's rewrite C. So C is equal C of x, so the expression inside of the limit is equal to minus sinus of 3x over minus sinus of 4x, which is equal to sinus of 3x over sinus of 4x. And what is the only limit we know about sinuses? Okay, so quotient of sinuses like that, which have the form of 0 over 0 when x tends to 0. We know that limit of sinus x over x is equal to the limit of x over sinus x when x tends to 0 is equal to 1. Okay, so now we want to make that kind of expressions appear. And we have to remember before dividing by x that we've got x which is different from 0, because we are taking the limit in x tends to 0. So x is not equal to 0. And we want to make appear a 3x and a 4x. So we are going to write C of x as, so sinus x over sinus, 3x over 3x. But you see, I divided by 3x, so I will multiply by 3x times 4x over sinus of 4x. So I made this 4x appear. Let's divide by 4x as well, because I don't want to change anything to my expression. Let's simplify those two useless x's, and we'll have C is equal to 3 over 4 times sinus, so 3 over 4 times sinus of 3x over 3x times sinus 4x, times 4x over sinus of 4x. And now we know that this thing tends to 1 in x tends to 0. This thing tends to 1 when x tends to 0. So by product, okay, here you have to justify by saying by product. By product, we will have the limit of c of x when x tends to 0 is equal to 3 over 4 times 1 times 1. So 3 over 4 times 1 is equal to 3 over 4. We've got our c is equal to 3 over 4. We've just solved the first 3 limits of the exercise. We will solve the 3 other ones in the second part of the video. Hope you enjoyed this first part of the video. See you soon. Bye.